I've got only 3 minutes and 14 seconds to explain the concept of a derivative. Let's begin with something simple. A straight line on the Cartesian plane. Every straight line has a slope, right? So how do we calculate it? We pick 2 points on the x-axis. Let's call them x sub a and x sub b. The slope of the line is defined as the change in y divided by the change in x. Now here's the amazing part. The slope of a straight line doesn't depend on which points you pick. It's always the same. But wait, if we're here to talk about derivatives, why are we starting with straight lines? Let's switch to a general function. What we want is to understand the slope of the function at a single point. Let's call that point x naught. Here comes the problem. This isn't a straight line anymore. So, how do we find the slope? We bring back the idea of a line, but this time, it's the tangent line to the curve at that point. So once we fix x naught, we define the slope of the function there as the slope of the tangent line. Now let's translate this idea into math. We fix a point x naught and pick another point just to the right. Let's say x naught plus h, where h is positive. We draw the secant line that connects these 2 points. Its slope is, but hold on, that's not the slope of the tangent line. Here's the clever idea. As h gets smaller and smaller, approaching 0, the secant line starts to behave like the tangent line. So we take the limit of that slope as h approaches 0. If that limit exists and it's a real number, then boom, we've found the slope of the function at x naught. And hey, if you're wondering what a limit actually is, I've got another video that explains it. Also in just 3 minutes and 14 seconds. Links in the description. Let f be a function defined on an interval I. If for every point x naught the following limit exists and is a finite number, then the function f is said to be differentiable, and we can define another function f prime as follows. This function, f prime, is called the first derivative of f. So, did I explain derivatives in 3 minutes and 14 seconds? If it's clearer now, mission accomplished. Don't forget to subscribe. Let me know in the comments what you think, and see you next time.